Hey there, in this video we're going to be talking to the Motor Oil Geek about the difference between engine oil, transmission oil, and differential oil. The differences in the characteristics of each and then how to best maintain them.
We always say that application dictates chemistry.
Right.
And this is a perfect example of that. That from a mechanical standpoint, engines, transmissions, and rear differentials are actually very different. Now, the biggest difference between an engine oil and really everything else, including turbines, is exposure to combustion. Only piston-driven engine oils have to deal with combustion byproducts. And that's the main reason why we have to change engine oil so much more regularly than you do every other fluid, is that oil is going to do exactly what it's designed to do unless it's acted on by one of only two things: temperature and contamination. Engine oils experience constant contamination because of combustion. Unfortunately, and I hate to say this because it breaks my heart as a piston ring kind of guy, piston rings are not 100% effective 100% of the time. So you're always getting some combustion blow by, some degradation products into the oil. They're contaminating the oil and making the oil go bad. So engine oils are formulated primarily to deal with that. Detergents, dispersants, all kinds of those things are really about dealing with the byproducts of combustion. The great thing when you come to, say, a transmission or a differential is now you don't have that anymore.
Right.
So literally, these three fluids right here, you can all make them from the exact same base oil. So the difference is in the additive package.
Interesting.
Not the base oils. So for example, you go, say, Richmond, California, outside San Francisco.
Yeah.
Chevron has a giant refinery there, and they make base oils. Those base oils, they say, it's called 100 neutral. So 100 neutral base oil can actually be used to make ATF, engine oil, and be a component in gear oil.
Wow. So you could be putting the same base oil in all the parts of your vehicle.
Oh yeah, absolutely.
And you probably are. Because there's
100%
there's only four different, I think you said 4 different manufacturers that make base oils.
They make additives, right? So you have 4 companies that make additives. You got about a dozen companies that make base oils.
Okay.
But yeah, when you go to a blend facility, they're going to have their base stocks.
Right.
They're going to use those same base stocks at different ratios to make everything they make. From hydraulic fluid, transmission fluid, engine oils, gear oils, they're using the same basic base stocks. Now, again, there's some adjustments to be made for viscosity reasons because they're not all the same viscosity fluids, obviously, but the base is the same.
Okay.
Really the difference is the additive package is going to be very different. And one of the key differences between a gear oil and a transmission fluid is going to be down to the clutch compatibility. So when you have ATFs, one of the big reasons why I'm a big proponent of using the OEM ATF in most cases is because they've tested that fluid with the friction materials in their clutch.
Okay.
Not every transmission manufacturer uses the same clutch materials. Some clutches are made out of carbon fiber. Some clutches are made out of copper type, alloys. Some are even made out of aluminum for weird reasons. And so you have centered materials, you've got cellulose materials. Bottom line is there's a wide range of clutch friction materials in use across all different automotive applications. When you're talking about a single OEM and their OEM factory fill fluid, that's what they've used to validate, and they've made changes to that fluid to make it suitable for the seals and the clutch friction materials. So in that regard, I'm a big fan of that. Now, does it mean you can't use an aftermarket fluid that meets those requirements? But it's really critical to understand there's a difference between recommended for and meets. If it meets, it means that the additive supplier that sold whoever it was that blended it, the additive package, they've actually already done the testing with the OEM to make sure that it's compatible.
Okay.
Versus
recommended, that's more of like a soft, like...
We think it's going to work.
We think it's going to work.
Yeah. We think it's going to work.
Right.
Based on our experience, we're pretty sure it's going to be good. But they haven't done all the formal testing.
Interesting.
So that's
a little tell there.
It is.
Yeah, when you're fluid shopping.
And because of the critical nature of the functioning of the clutch materials, that's why to me it's like OE fluid is your first choice. If it's expensive, hard to get, I understand it. If you use an aftermarket fluid, make sure it meets.
Okay.
And then see if it works for you. If it doesn't shift the same, then you know that you might want to go back to something else. Right? But when it comes to how often you should change them, everything breaks in. Engines break in, transmissions break in, gears break in. Now with engines, because there's a lot more contamination and there's a lot more wearing in of parts because there's more contacting surfaces, piston rings, cylinder walls, things like that, you end up having to do a lot of early oil changes to get all that junk out of the system.
That's the break-in period.
That's the break-in period. And we've seen the data, from the oil analysis, at Speed Diagnostics, we've got 15,000 plus samples, and it's really clear.
Yeah.
It takes about 15,000 miles for these things to break in.
Okay.
So that first 15,000 miles, you're going to need to do probably 5 oil changes.
Right.
During that period of time.
Right.
To be able to get all that junk out. Then your engine will be broken in and baseline. Then you can begin to make changes to see what, what's ideal for your engine and how you drive, where you live, and all those. Life's way easier when it comes to gear oils and transmissions. You need to change the gear oil and the transmission oil probably in the first 5,000 miles.
Right.
Just get it out because there is break-in. Nowhere near as much as the engine, but it does happen. Change it, get it out. Then probably your next one should probably come around 20, 25,000 miles. Get it out again because you didn't get all of it out, but you got most of it out. The next one, it'll get it out. Then, based on how severe your operating conditions are, that will determine how far you can go on the next one. But the good thing is with gears and transmissions, they're not getting contamination in from the outside. So really,
they're not experiencing combustion.
No, no. So the only contamination is the built-in contamination from break-in, which you're removing in that first 25,000 miles. So those first couple of changes, you're getting that out. Then you can go a lot further based on temperature.
Right.
Like we did another video, we talked about temperatures, right? So for every 20 degrees Fahrenheit, you increase the operating temperature of the gear or transmission, you cut the life of the oil in half. Now, you're starting from a really, really long life. You're chopping it back. So where with an engine, you don't want to run it too cool because you're hurting the effectiveness of the additives. With transmissions and gears, there's no combustion byproduct, there's no water, anything else happening
that you need to get out.
You'd be more ideal keeping that at a lower temperature.
On the cooler side.
Yeah.
Interesting. Yeah, so because you're not using the heat to expel the fuel dilution or to clean the oil to get the additives to work, or sorry, the detergents. Yeah.
You don't need that. And the thing is,
interesting.
These additives, especially like gear oil additives, the extreme pressure additives, it's not like the ZDP in engine oil, where ZDP in engine oil needs bulk oil temperature to help it
to function well.
I mean, it will still function at a atomic level, but it functions better when the bulk oil temperature is higher.
Right.
Gear oil additives don't care.
Right.
That they will do their job at preventing welding, even if the oil is dead cold.
Interesting.
Because it's reacting at the metal surface.
That's really, really cool. And that, I think, is the crux of this whole video that I wanted to really get at, is that, like, that chemical level, where are the differences? And that, again, that sounds like it. They were, built, facilitated for a specific job, and your gears, the temperature down there is going to vary a lot. You know,
Oh, yeah.
your pumpkin's exposed to the outside, to the road, to
Well,
the
perfect
ambient air
example.
temperature.
They don't put ZDP in gear oil. So ZDP is an engine oil additive that prevents wear. So engine oil is going to be, have anywhere from 800 to 1,200 parts per million ZDP, but either gasoline or a diesel or what kind of diesel engine oil it may be. There's none in gear oil because gears experience what's called extreme pressure, where ZDP is an anti-wear additive. You need sulfur-based or phosphorus-based extreme pressure additives because of the extreme loads, that contact point of those gears sliding in contact, especially a hypoid rear end. You have that high sliding force.
Right.
Those loads are so high, the ZDP film won't get the job done. It's too much. So you're using a completely different type of chemistry. There's really no detergents, no dispersants in gear oil. Now you may have things like limited slip modifiers that are in there designed to adapt for that. So again, the chemistry in gear oil completely different than an engine oil.
Interesting. Now, how does the gear oil then differ from the ATF?
Again, ATF completely different than gear oil. Because ATF now you don't have that hypoid where you have that sliding contact. You have pure rolling and you've got clutches.
Okay.
So
it's not a high pressure formulation and it's not formulated for contaminants. It's made for the gear contact.
Right. And really ATFs are optimized for the clutch friction.
Okay.
So you want the clutches to grab.
Right.
So but you don't want it to shudder. So you're trying to balance static and dynamic friction.
Okay.
So friction of something to get it to move is different than the friction when it is moving or to stop. So the thing about clutches, you're trying to hold all that torque. So you need a high static friction so that it doesn't slip.
Right.
But when you're engaging and disengaging, you want a low friction. But you need to have this transition.
So like the dynamic friction is low, the static friction is high.
Right.
For a transmission to function
And you
properly.
want that transition between the two to be smooth so it doesn't shudder and jerk.
Wow.
So yes,
Yeah.
there's engine oils are going to probably contain typically, we'll call it 8, 9, 10 different additives making up the additive package in this. Gear oils 4 or 5.
Wow.
ATFs like this 16.
Wow.
Yeah, these are way more complex in terms of all the different additives for the seals, for the gears, for the clutches. Because what people don't understand often is that every time you put in an additive, you get some positive benefit otherwise you wouldn't have put it in. But it normally brings along other characteristics you don't like. Like ibuprofen's great to get rid of your knee pain, but if you take it on an empty stomach, it's going to make your stomach hurt. Right?
There's side effects.
There are side effects. So a lot of times the complexity of an ATF is dealing with the side effects. Like, I got to put in this additive to protect this gear, but that gear protection is now affecting this seal. So now I got to put in this seal conditioner to make up for this additive over there.
Wow.
This is why you don't put stuff in your oil, right?
Yeah.
There's a lot of work that goes into making sure these things work correctly for their intended application.
Right.
When you play backyard chemist, you are going rogue, and it might work for you or it might work badly for you. I wouldn't want to risk it.
No, not worth it. Especially with how much work's gone into formulating these.
Oh yeah. This won't work well in a transmission. That won't work at all in the rear end.
Yeah. Wow. Well, that is really, really cool. Thank you. And it sounds like for maintenance for all of these, at the end of the day, especially for break-in, you just got to change it and then get the bad stuff out. And then once you've established, a testing regimen and you kind of have a, routine, so to speak, you can kind of build on that. But it sounds like, especially when you're breaking in, like you definitely, and I think you did a video on this recently,
Yeah.
right? Talking about break-in oil changes, and a lot of OEMs, tell you to even go longer than you probably should on break-ins.
Yeah, and I think a lot of that is based on cost of ownership and trying to make life easier for the customers.
Right.
And there's like a lot of things in life, there's what will get you by versus what's best.
Right.
You know, I always make the analogy that, C's get degrees in college, but if you want to be valedictorian, you're going to have to work harder.
Right.
And, both have a diploma at the end of the day.
Right.
But so if your C's get degrees, then you can just follow what's in the owner's manual. Just do what they tell you to do.
Right.
And you don't have to think about it. Done. But if you want to get maximum life out of the vehicle, you're going to have to work a little bit harder than C's get degrees. That's where the early oil changes to remove the break-in debris, that sets you up for longer life, because it's public domain knowledge that the higher the level of contamination, the shorter the equipment life is.
Right.
So the only way to get that stuff out is to change it, unfortunately.
Yeah.
There's no filter that will take it all out. There's no magic molecules on that, or magic filters that remove everything. So do the oil changes, get it out, then you can follow the advice of the OEMs past that as your starting point. And then the oil analysis can give you the tool to fine tune that for what your use case is, right?
Right.
Some people are going to do a lot of highway driving. Highway driving is actually a lot easier than short trip start-stop. So finding what works best for you, where you live, how you drive, temperature influences on things, all that's going to factor into what's right for you. The typical one-size-fits-all advice is kind of like one-size-fits-all tools and clothes. They don't typically fit anything well.
Right.
They're functional.
They'll work.
Yeah. But they're not ideal.
Yeah.
Back to C's get degrees or valedictorian. You got to choose what you want to be first.
Right. Yeah, you can get plenty of life out of your vehicle. And I think I've seen plenty of people do that, just following OEMs or changing their oil pretty often. But then it's like, if you really want to go, A tier, then you can work in the analysis and start testing different stuff. And I think for me, what's been really cool about the testing process is also learning about how oil behaves, because I think oftentimes it's easy to be like, oh, well, you're just, is it really worth it just to try to save a couple bucks on an oil change? And I'd say for the break-in period, what you're saying is don't try to save a couple bucks, you know what I mean? You definitely want to change the oil. But I think understanding how it behaves can really help you understand your vehicle. And again, you don't have to do that. But if you're into it, I love tinkering and learning about this stuff. And I think it's cool to kind of take that to the next level. It's the whole reason why I started this channel. So.
Well, and the whole point is the reason oil analysis even became a thing was to extend equipment life and reduce maintenance cost.
Right.
Those are the two reasons to do it. Like, if you just want to follow a set schedule and not worry about it, then you're basically saying my equipment life is going to be whatever it is. I'm not going to try to influence it.
Right.
And my maintenance costs are fixed because I'm following the schedule. And yeah, that's a fine thing to do. There's no problem with that. But if you want to go to that next level and get maximum possible equipment life, lowest possible maintenance cost, you have to measure what you're doing. That's predictive maintenance, not scheduled maintenance.
Right.
And oil analysis is a predictive maintenance tool, one of many. Like, you mentioned the Banks iDash in other videos, right?
Yeah.
That's a great way. You're getting data. That way you're making decisions based on real data,
right? Not
opinion or speculation.
Right.
Because we can't really trust ourselves to think. We got to look at the numbers, because we will imagine things that aren't real sometimes.
Yeah. Oh, I do it all the time. Like I was telling you earlier, just hearing things, imaginary clicks and clunks.
We all do.
And, you're worried about your car. And then, oil analysis pretty much puts those concerns to bed, at least from an engine perspective. But I've talked about that before too. Human beings, we all have these built-in biases that we're wired with, and it's super easy. That's one. I have a video where I talk about keeping a maintenance spreadsheet, because just because you think you changed your oil or did your differential 30,000 miles ago, if it's not written down, it didn't happen.
Absolutely.
I believe that, truly. I mean, and you can do all the maintenance you want, but if it's not written down, didn't happen.
Yeah.
So you gotta fight the biases.
Like a flight logbook.
Yeah, exactly.
If it's not in there, signed off on, it did not happen.
It did not happen, yeah, exactly. Well, thank you so much for your time. I really appreciate it, and I appreciate all of you being here to watch us. If you have questions for Lake or I, please drop them below, and we'll see you next time here on Power Stroke Maintenance. Cheers.